Hi students, we are now going to study about the projectile thrown from a car. Any practical problem related to this type, I want to discuss the way with which we have to proceed to get the desired answers. I will just discuss how to apply the equations of motion to study this theme. That will be my main motto. So, I want to discuss very basic observations which we may analyze to solve this entertaining problem. Let us consider a car which is moving with velocity v naught along a straight road. Driver of car throws a ball with initial velocity u relative to car in a direction making angle theta with the horizontal. The height from where the ball was released is h. We are taking our reference frame is xy coordinate system such that positive x direction indicates the direction of motion of the car and y direction, positive y direction is vertically upward. Now, under the situation as we had previously done, we will observe initial velocity and acceleration of the projectile during its flight in order to use further equation of kinematics. Here, what we can observe from this reference frame which we have assumed here, just see initial velocity vector u can be written as its two components. One is x component which is along positive x direction and next y component of velocity of projection which is vertically upward. We can easily see here that ux is u cos theta, so it's I cap plus u sin theta which is along j cap. So it is the velocity of the projectile with respect to the car. Remember here, this u is relative to car. Now, as we know, velocity of car, it is v naught I cap. So, velocity of projection of projectile with respect to ground can be taken as velocity of projectile with respect to car plus velocity of car with respect to ground. So, u with respect to ground for the thrown projectile, it is equal to v naught plus u cos theta I cap plus u sin theta j cap. Remember, this is the velocity which we have to use in further calculations about this thrown projectile. We can easily say an acceleration of projectile A can be written as minus g j cap. This is the second information value to solve further various parameters related to the projectile which has been thrown from this car. Now, what we can do here, the first thing which we may require to find to get time of flight, we will use equation of kinematics number 2, which is given as S equal to ut plus half a t square in one time of flight t equal to capital T. Capital T is being used here as the symbol for time of flight. Displacement S can be written as u cos theta plus v naught into time I cap plus u sin theta t. So displacement as u cos theta plus v naught into time of flight I cap plus u sin theta t minus half gt square j cap. So as in one time of flight y displacement is minus h, here note the sign minus because y displacement in one time of flight is equation with minus h. We get an equation solution to which leads us to the time of flight. It is a simple quadratic equation which can be easily solved, and we will get answer for the time of flight using this equation. Here you can easily see that here displacement x can be written as x I cap plus y j cap in terms of x and y components of displacement. We can get our final calculations. So the equation now can be reformed as gt square minus twice u sin theta into time of flight plus 2 times h equal to 0. Solution to which can be written as twice u sin theta plus minus under root of 4 u square sin square theta plus 8gh divided by twice g. I want to suggest you that don't try to remember this typical form for the time of flight. Just follow the procedure which I have taken here with the given data-based questions. You can very easily find this relation. It will become very short to you. So no need to remember this typical form of time of flight. Just go through the process. Now, once we get time of flight for the projectile, we can easily find further another things like horizontal range. Horizontal range with respect to ground, it can be obtained using u cos theta plus v naught time of flight. If we want to get range with respect to car itself, then this range with respect to car can be obtained using u cos theta into time. What we are doing here, we are taking the velocity of the projectile with respect to ground itself. So similarly, we can get maximum height above the ground by calculating maximum height above the point of projection plus the height from where this projectile is initially thrown above the ground. So I think you have got the perfect knowledge what to do and what to not under this type of circumstances. So, happy learning. Bye.